Alexa, what day is today?
Today is Wednesday, May 16th.
Alexa, what time is it?
The time is 8:44 a.m.
Alexa, turn on light one. Hi. I'm Linton again, and this time it's not part of the most dreaded terror series. This is not nearly so scary. We're not talking about extinction. We are talking about, billions dying under less than pleasant circumstances, but it really isn't as bad as what we've been talked about before. Went through that. I've already given you the best. So back to today's subject is a possible ice age. This is speculative. I could be wrong. So let's get started. Okay, you see there's a globe here. I'm holding a globe in my hand. It's a model of the Earth. It's round. North is portrayed up here. And then south is down here, South Pole. Don't worry about the magnetic poles right now. We've got this big thing, all right? And a couple of three numbers. One is when sunlight strikes ocean water, 90% of the energy is absorbed. When sunlight, this is the North Pole, remember? Okay, we've got the North Pole, we've got an ice cap. When sunlight hits glare ice, 90% is reflected. Here are the continents, where are we? All right. When sunlight hits land, call it 50-50. All right. Now then, as you see, like most globes, really, it's mounted on a stand. We've got a stand that holds it tilted so that the South Pole is around here, North Pole is up here, instead of, as you'd think, a sensible designer would put the North Pole straight up to the top, because that's the way we hang flat maps, the Mercator projection. But on a globe, you tilt it. The reason for that is that the Earth's spinning. We know that. We're on the outside, a number of minority reports notwithstanding. The North Pole, the axis, you go out north, it's a place that's basically like the North Star, okay? It's out that away. And the Earth goes around the sun, a big circle, but it continues, the axis continues pointing the same direction in space. Plus or minus something called the precession of the equinox, which is not something we need to worry about. Takes a long time to happen. So basically we're, all right. So sometimes now, instead of moving the Earth around the sun, we'll just move the sun around the Earth. At this moment, the sun is over here, all right, shining mostly on the southern hemisphere, and the northern hemisphere up there is fairly much in the shadow. Sun coming in this direction. Here's the sun, illuminated southern hemisphere, less illuminated northern hemisphere. 6 months later, the sun is over yonder, shining SOA. All right. Now we have an illuminated northern hemisphere and a relatively less illuminated southern hemisphere. Sunlight came this way, right? Well, when the sunlight's hitting here, it's called northern hemisphere summer. It's southern hemisphere winter. When the sun is coming this direction, the axis is positioned so it's pointing as far as it can away from the sun. It's southern hemisphere summer, northern hemisphere winter, more or less. The seasons lag behind the sun a little bit. Yeah, don't worry about it. Just let's say hot up here, cool up here, cool up here, warmer down here in terms of how much sunlight hits. Now then, got another toy for you. This is gonna, I'm sorry it seems so cheerful, but this is so much less of a problem than what we've been doing before. Okay, here in my strange and wonderful travels is a model of a 30-degree right triangle. I suppose at one point I thought I was going to do some clever design at a time in which the computer wouldn't wait to do it. All right, got this. Two sides are at right angles to each other. Can you see that? I know. All right, good. Two sides at right angles to each other. There's one side. There's another side. All right. And this side here is the hypotenuse, right? Now, you remember from grammar school, that's the hypotenuse, the diagonal. I hope you can see that. All right, the diagonal is the hypotenuse, straight up, straight over, and on the diagonal. And the Pythagorean theorem is the square of the hypotenuse of a right angle triangle is equal to the sum of the square of the other two sides, and that will hold for this. It's a right angle. More importantly for us, the ratio of this distance, right, across the base. See that? That distance, what I can reach with those two fingers. If we come up to the hypotenuse, there is it 1, 2, 30-degree right triangle. The shortest side is always twice the longest side. I don't care how big or how small you make it, that will always be true. This geometry, well, it picked up that in the same class where you got the Pythagorean theorem. All right, so the globe, the axis of the Earth, is approximately 30 degrees off the vertical. You got that? So this angle here, from there down to there, right along that, right there, right? That axis, the axis, the North Pole, remember, always points at the North Star. That away. And the distance it is from vertical, assuming they're in the plane of the ecliptic, right? The plane of the tabletop. Distance from the vertical is about 30 degrees, at least it's in the 20s. We're going to say it's 30. Okay. So, imagine this triangle way up north, okay? You got the edges of it there, there, and there, right? We're way up north with this thing. And the shortest side is sitting on the snow, right? We'll take it all the way to the North Pole, and we'll wait for the moment when the axis of the Earth is pointing as close to the sun as it ever gets, which happens on the first day of summer. So summer is basically starts when the sun has already reached its maximum deviation from vertical, the summer solstice. All right. So here is this, let's say the sun, which is 30 degrees above the horizon. Remember, we're at the North Pole. We tilted 30 degrees toward the sun, so we are getting a sun 30 degrees above the horizon, right? So what you see this line here, that is the edge of our triangle. There. There's another edge there. There's another edge here. So sunlight coming in here fills the whole area covered by the hypotenuse of the triangle. So this much sun coming, this way, as it hits at that angle, goes through a window, virtual window there, and then spreads out along the ground. So whatever the incoming sunlight is from there, it's getting reduced by 50% because it's spreading along the ground. So this side of this triangle is getting sunlight at the same rate as if you're at the equator, at the equinox, at the moon, looking straight up, full drenching sunlight. But by the time it hits the ground, it's only 50%. Right? But there are spins. The sun's not moving much in our frame of reference. But here at the equator, right? Got your equator there. There's the equator. For the equator, at the equinox, when the sun is absolutely over the equator, close as it can get, you only get 12 hours of sunlight in a day. Whereas at the North Pole, at the solstice, you're getting 24 hours of sunlight a day. Remember, the sun's over there, sunlight's coming this way, it continues to hit hour after hour, day after day. It doesn't stop. So you're getting as much sunlight, assuming the 30-degree number, which is an approximation. You're getting as much sunlight at the North Pole at the summer solstice as you do at the equator, at the equinox. No. You reduce it by 12 hours, so they should be equal, but whereas the sun at the solstice, looking with the North Pole, looking at the sun during the solstice, gets it 24. At the equator, at the equinox, yeah, you got 12 hours of sunlight, but a lot of that time, well, almost all the time, the sun's never quite overhead. It's rising. Over the first 30 degrees or a 12-hour day, you're below the 30-degree angle, so you got 30 degrees going up, 30 degrees going down. You've lost 30 degrees of your 180 already, just considering rising and falling, and it's actually, you lose more than that because sun goes below 30 degrees. The amount of energy you're getting drops off and off. So, substantially more heat, light, energy striking the Earth at the North Pole, at the equinox, at the solstice, than any place else on the world. The equator at the equinox doesn't get half that much energy shooting in. So how much gets absorbed? Well, let's look and see. We got ourselves, here's the North Pole. Nature's not an equal opportunity process. It got a lot of land up north. It got not that much in the south. Right, a lot of ocean in the south half of the globe. And you remember, ocean absorbs almost all of the energy that hits it. Ice reflects almost all the energy and lands in between. So the sun at the North Pole, even though more energy is coming in, more than twice as much, it's reflecting off the ice. Bing, bounces off, doesn't stay. All right, let's talk about airflow. Here's the equator. You got the equator? You like looking at the equator, okay? In the globe, it's doing this. Middle of this, at the equinox, when the sun is right over the equator, or the equator is angled right at the sun, hot air rises all the way around the world, right? At the equator, you're always getting hot air rising. It rises, then it spreads north and south, and then it falls again. As it falls, falling air can hold more water. It's a drying process, and right about this latitude, okay, like there's Lower California, a lot of Mexico, Florida. I'm just coming around. Sahara Desert, Arabian Desert, middle of India, China. Oh, they got water in China, but it's all melt water from the Himalayas. Yeah, and then we come on out and come across down to America. It's deserts, same thing that's happened. That's because the air, having risen to the equator, is dropping and now drying. As it goes back to the equator, the same air is spinning more or less at the speed of the surface of the earth. So relatively little wind in the desert zone, but as it comes south, it's having to travel farther and farther in a 24-hour cycle so that it's matched up with the equator. And what's happening is the Earth's turning faster than the air, and you get the trade winds that blow eternally and diagonally. Not quite eternally, and that's a problem. Okay, ignore that. At the North Pole, all that energy got reflected. It's cold. You got falling air. There's very little precipitation. Then, as the air falls, it's sucking air out of the temperate zone. And as the air gets sucked out, it's going through a smaller and smaller circle. It's got less and less land to follow every 24 hours. So it appears to speed up. That's your jet stream. It can wobble, but basically you got this high altitude jet stream going this way, drags atmosphere below it along, and you get your prevailing westerlies. Your line storm coming out of the west over the plains. Now, of course, the wind can blow in any direction, any place. But there's a strong tendency for weather systems to move from west to east. All right? There's the basics. And now, let's just pretend something. Pretend like something's going to happen. Let's say the Arctic Ocean melts. No ice cap in the Arctic. Don't worry about the Antarctic right now. No ice cap. And there's calculations. When it used to be. And 200 years from now, there won't be, that the Arctic Ocean will be ice-free. That estimate is getting smaller and smaller. and isn't the estimate to worry about. Estimate to worry about, here, take a look at the North Pole, all right? It's all ice. When the ice is all gone, and we'll refine that a little bit. When the ice is all gone, now the North Pole is getting 24 hours of 50% sunlight. In other words, it's getting more than twice as much as, well, a lot more than the equator ever gets, or any place in the world. And most places in the northern hemisphere, there's a lot of land that reflects a lot of sunlight. Here, Arctic Ocean, it's all black seawater. It's all getting absorbed. So you have this huge amount of energy being absorbed by the Arctic Ocean. What happens? Hot air rises. And here's the scary thing. This is the scary thing. Nobody talks about it. It's like, other things I worry about. It is absolutely, no one wants to say that there will come a time, and in the middle of the winter, this past winter, it was 32 degrees at the North Pole for substantial periods of time. It was thawing in the winter, northern hemisphere winter. And now, I'm here in Florida, we get these chilly, dry north winds. Since the dead of winter. It's pleasant, it's nice to be outside, the sunlight. But that means the jet stream, instead of going this way across the country, west to east, the jet stream is looping way south, and we are getting, where are we? Okay, there's Florida. We are getting a high altitude air. That means the high altitudes are getting low altitude air, right? I'd think. Low altitude air is, at present, warm. That Arctic ice sheet could go anytime. They don't even have real good measurements of its volume. They keep saying, the surface area. I don't give. The surface area matters in its effect, doesn't matter to the timing. The last quarter inch of glare ice does just as good a job of bouncing off that sunlight as 40 feet of ice. It just disappears faster. All right, so huge mass of hot air. Here's Florida again, right? And from there to there, something like that. If I jump in the car and drive north in the general direction of Jacksonville, I might go through a thunderstorm. And then it clears up. And then I might go through another, a really heavy one. 80 miles apart is plenty of room to build up a serious thunderstorm, thunder and lightning and hail and wind and torrential rain. Right. That's a circle 80 miles across. You're pulling energy from that. But as this hot air is rising off the North Pole, it's pulling energy in from an area 8,000 miles across. And another 8,000 miles across the other side. Okay, so it's not just 1,000 times the power of a regular thunderstorm. It's 2,000 times the power of a regular thunderstorm. Hailstones? know, basketball size comes to mind. I don't know. I've not been there. I don't have the calculations on it. I don't know how to do it. Somebody can do it, but they're not. So all this hot air boils off the North Pole, and then it's going to come back down. Well, the equatorial air comes down, after about here. We're in the desert zone right now, Tampa Bay, St. Pete, Clearwater area. And it's pretty much a desert here. The rest of the state gets a substantial rain. Yeah, okay, so that means the ice, the thunderstorm is going to could be coming down, probably across the northern United States. Or at the level of the northern United States. You see, when the hot air rises at the equator and falls in the desert zone, it started out widely distributed, got a little concentrated. When the cold air falls at the equator, it doesn't come into a real small area because the jet streams, the centrifugal force, the acceleration would take to turn and head into the pole, holds it out. So the hot rising air starts south and it wants to get to the South Pole. That's the coldest place. That's in shade. It's approaching the temperature of outer space. And it's starting out as a single little lump and gets drawn up. You get a whirlwind effect. It's a cyclone, and that cyclone, with all that energy, wants to go to the South Pole. And I imagine, right, so far, it's physics. From now on, it's speculation, right? Let me just say, I've told you the facts as best I can get a hold of them. The rest of them is speculation. Something's going to happen, there's a fact. All right? It starts out with this glob of ultra cold air falling down and trying to get south. And it just might line up along the east side of the Rocky Mountains. The world's going this way, headed to the east, so along the east side of the Rocky Mountains, it tends to channel that cold air, continues through Mexico. And then, guess what? Most conveniently, I mean, you just about have to think this is a conspiracy theory, right? As you pass the equator, there, you think, West Coast of North America, West Coast of South America, that was a huge step off. That glob of cold air that wants relatively hot air that wants to get to the South Pole, it was really hot when it started. It dumped a lot of heat, but it still is. That's where the whole world's energy supply is. It's relatively hot. It wants to get cool. Urge. Yeah, that's right. Energy means what things are urged to do or how much. So, hops down, and now it's to the west of the Andes. And it's tending to go faster than the world because we're getting to, shorter and shorter latitudes, and it all piles up along the Andes, channeled. And eventually, once it gets off past the tip of the Andes, it's in the dark anyway. It's happy. But of course it's anything north of the Antarctic Circle is getting sunlight. The winds across Argentina and lower Chile. Amazing, they say. Not been there. The Roaring Forties or whatever the with days of sailing ship. That was hard work. All right, so there you go. So wind from north to south pole. Speeds, whale, 1,000 times what a thunderstorm can develop. Supersonic speeds, not a figment of not impossible. A hail, half-mile thick layer of ice appearing. Well, I'd say overnight's probably a poor word because it's going to be awfully dark under all that ice. You remember, these was grasshopper glacier out in the American West. I never saw it. Yeah, I think it's almost gone now. But my father was describing, you'd take your horse up along the grasshopper glacier, and throughout the entire thickness of the glacier, as high as you could reach, standing up in your stirrups, all the way to the ground, there were grasshoppers mixed in with the glacier. That glacier formed within a 24-hour period. Grasshoppers could do wonderful things, but hopping around on ice is not their strength. So the grasshopper glacier appeared within a 24-hour period. There are mammoths found frozen with fresh flowers in their stomach, and I read an article, perfectly serious, straight-faced article, and he's saying, "Oh, well, you see, those flowers weren't really fresh. The mammoth, hand wave, doesn't digest the flowers until they get to the colon. So they eats it immediately goes to the colon. That's where digestion takes place. Unlike, birds and mammals. I mean, it seemed improbable on the face of it. And it misses the point. Okay, so it took 2 or 3 days to freeze an entire mammoth, and he's still frozen in the ice and only thawing out now. Yeah, cold. So yeah, the cold freeze mammoths in their tracks. Well, a mammoth wasn't starving if he could still walk, if he was still alive, he'd probably walk for 6 months without having to stop to eat anything. He'd just go to where there were more flowers. But no, too cold to move. There was a nice demonstration of it. It was a skeleton of a dinosaur. And the dinosaur was, maybe the size of a small car, and it had a head, like that big. A good handsome head size for a big animal. He said, he's a small head, big animal, not like an elephant with big head. No, a little head. And then it showed a section, it was modeled, a section through the skull. The bone was that thick, right? On 2 sides, he had a little bitty brain. Everything else was bone. Now, what does he need that much bone for? Well, if he's got hailstones coming at him at supersonic speeds, might be kind of handy to, keep him alive long enough till he gets behind the ridge. So there you go. New ice age. Glaciers appearing sporadically, one here, one there, from maybe not every year. Glaciers so thick that they'll never go away in the lifetime of anybody, of people now. The cold northern moving air getting warmer and warmer. Global drought every year. Now then, of course, when the sun goes to the southern hemisphere, everything gets back to pretty much what we have now, except, of course, that there have been maybe some famines. Anyway, that worries me. the thing that worries me most is that nobody else but me seems to have noticed that there's something to be done, something to be studied, something to be understood. I'm sorry about your Large Super Hadron Collider and your space missions and your genomes of cancer cells and all that. That's all very well and good. Nice Boy Scout stuff. Why don't you grow up and do something important like figure out what is going to happen when that ice pack melts? It doesn't have to melt completely. Just give me a circle 100 miles in radius around the geometrical North Pole, and things will start to change. I think. I haven't been there. I don't know. I'm not even have the credentials to figure out. But that's something to concern. Look, we've survived ice ages before. If we weren't threatened with extinction on other bases, we'd survive that. Meanwhile, up here, if you go to nobabies.net, you will find this is the homepage there. Let's see. And if you go down to YouTube links, which is right there. Do you see it? Maybe not. All right. Let's see if I can get a cursor on that. Yeah. All right. Right there. YouTube links. You see it? It's not that far. And then there's the right below that is the video scripts. And that's all the other stuff I've done, and I'll put this there too. So take care, have a good one. Don't let this one spoil your day. There are more important things to worry about, but this is one of them. Alexa, turn off light 1.